right. So factoring is something that you first learn about probably in Algebra 1. And it comes back, and it comes back, and it keeps coming back. And I find that most students need a review every time it returns. So that's what this screencast is going to help you do. This is just sort of a flow chart, an instructional flow chart that will help you, and then you've got some problems that go along with this so that you can practice on your own. But we're just going to go through each type, and hopefully it will just be a refresher. So the first type, first of all, factoring polynomials. All of these polynomials that we're going to be factoring in this screencast are quadratics, meaning they're second-degree polynomials. So the first ones we're going to look at are difference of squares, difference of two squares. So if you think about, these are two terms, and each of these terms is a perfect square, meaning it has factors that it has one factor that you can multiply by itself to get that number. So for instance, 64 is 8 times 8. 25 is a perfect square. 36 is a perfect square. X squared is also a perfect square because x times x is x squared. So when you factor the difference of two squares, it's essentially just the product of the sum and the difference. So the product of the sum and the difference of the square root of each term. So the square root of the first term, square root of the second term. And that's how you factor the difference of two squares. It's very simple. So if I were to FOIL this back out or box it back out, multiply it back out, I would get x squared minus 64. The second one, if you remember up here, the first thing you should do when you're factoring is look for a greatest common factor. So I didn't do that in the first one because there weren't any, but there is a greatest common factor in this second one. And oftentimes when a problem looks difficult, that's a good place to start to see if you can simplify it. So both of these terms have a 2 as a factor, and they both have an n as a factor. So I'm going to factor out a 2n from each one of these terms, and then that leaves me with 9m squared minus n squared. That looks a little simpler, and it also leaves me with another difference of two squares because 9m squared is a perfect square and n squared is a perfect square. So then I can factor that as the product of the sum and the difference of the square root of the first term and the square root of the second term. So then this ends up being 2n times 3m plus n times 3m minus n. And that's how you factor difference of squares. The next type of factoring is just a very basic quadratic trinomial where the lead coefficient is 1. There's no number here, so we know it's an understood 1. And so you're going to look for two factors of c that add up to b. And actually, this is the AC method. I don't want you to forget that there's a coefficient there. So what I'm going to look for is I'm looking for two numbers that multiply to give me negative 42 that add together to give me negative 1. And if you think about that, there are several different ways you can multiply and get negative 42, but the only way that you can add those two numbers and get negative 1 is negative 7 and positive 6. So those are my two factors, negative 7 and positive 6. I call that a magic pair. So then in this, immediately I can go, because this is a lead coefficient of 1, I can go straight to my factors, x minus 7, x plus 6. And your negative 7 or your minus 7 comes from here, and your positive 6 comes from there. So this next one, it looks a little tricky because the numbers are so big, but remember, you want to look for a greatest common factor first. So I can factor out a 2 from each one of these terms. So that leaves me with w squared plus 10w plus 25. Now I have a quadratic trinomial with a lead coefficient of 1. Can't forget that 2 because that's part of the problem, part of the expression. But what I've got is this quadratic trinomial right here. I'm looking for two numbers that multiply to give me 25, that add to give me 10, and those two numbers would be 5 and 5, so that's going to factor to be x plus 5 times x plus 5, which I can leave like that, or I can write it a little more simply, a little more concisely like that, 2 times x plus 5 squared. All right, this next method, my guess is you may not have ever seen this method. This is a method that I had never seen before. It was the last one I learned. I didn't learn it until I was a teacher, and one of my students showed it to me. But this one is a trinomial factoring when your lead coefficient is not 1. So we're looking at a situation where a is greater than 1. And again, the first thing you want to do is see if you can factor out a greatest common factor. So all three of these terms are divisible by 3. So I'm going to factor out a 3. And that leaves me with 10x squared minus 9x plus 2. All right, so then my next step, and this is more of an algorithm. This is just kind of a way to memorize doing it. This is not the preferred way, but if you really struggle with it, this way will work. And it's once you learn it, it's pretty easy. So we're just going to bring the 3 down. And for just a minute, we're just going to play around with this with this trinomial, and we're going to rewrite, take the a and the c and multiply. I'm going to rewrite this as x squared minus 9x plus 20. And then I want to factor this trinomial here. So I can factor this. I'm looking for two numbers that multiply to give me 20, that add to give me negative 9, so that's negative 5 and negative 4. So then I'm going to factor this as x minus 5 times x minus 4. Then I need to go back in and add that 10. So I'm gonna slip and slide. So I slipped, and now I'm gonna slide that 10 back underneath there. And that looks a little weird because that's an improper fraction. So I need to, this becomes x minus 1/2 times x minus 2/5. And then I'm going to slide that 2 back around in front and slide that 5 back around in front. So that gives me 3 times 2x minus 1 times 5x minus 2. And there you have it. There's the fully factored form. That's a little weird kind of way to do it, but some students it really works. So hopefully that, if you've really struggled with factoring, that may help you. And then probably the way you learn this most recently, and the way you're most used to doing it, is just trinomial grouping. So this again is, you're using, this is used for factors, for polynomials where a is greater than 1. And we can't factor out a greatest common factor. So there's nothing that goes into all three of those numbers, 2, 9, and 18. So I'm going to have to factor this by grouping. So again, I'm going to start out the same way. I'm looking for two numbers that multiply to give me a times c, so negative 36, that add together to give me positive 9. So there's several different ways I can get negative 36. Let's see, we've got 1 and 36, we've got 2 and 18, we've got 3 and 12, we've got 4 and 9, and we've got 6 and 6. And so the two that are going to combine, and I'm going to need one to be positive and one to be negative, because it needs to give me a negative product. So I know it's going to be this pair right here. And I know I need my 12 to be positive and my 3 to be negative. So now positive 12 times negative 3 gives me a negative 36. and positive 12 minus 3 gives me a positive 9. So that's my magic pair. Now I'm going to take that magic pair and I'm going to rewrite this 9x using that magic pair. So I have 2x squared plus 12x minus 3x minus 18. And all I did was I rewrote this, I expanded this 9x. Now I have 4 terms, and I'm going to factor these 4 terms by grouping. So I'm going to group the first 2 together, group the second 2 together, and the first 2 have a 2x in common. So I'm going to factor out a 2x, and that leaves me with x plus 6. You can see that right there. And then the second 2 have a negative 3 in common. And I'm going to factor out that negative 3, and that leaves me with x plus 6. And then if you've done this correctly, these 2 terms that you have here are going to match, which they do. So those become my first factor. And then the 2 leftover pieces become my second factor. And now I've factored that expression. Another way you may have seen this done is instead of doing it linearly, I think several of you in my previous class said that you typically do it with the box method, which is perfectly fine. So your 2x squared is going to go here, and your negative 18 goes here. And then this magic pair that we come up with is going to go in these 2 boxes, and it's not going to matter which one goes in which place. So I'm going to I'll put the 12x here and the minus 3x here. And then I want to look at the rows and the columns to see what they have in common. So first, I'm going to look at this first row to see what they have in common, and they have an x in common. Then I'm going to look at this second row to see what they have in common, and they have a 6 as a common factor. And then I'm going to look at this first column to see what these 2 terms have in common, and they have a 2 and an x in common. And then I'm going to look at the second column, and they have a negative 3 in common. And then I've just got to go back and kind of deduce what sign I need here. If this is a negative 3 and this is a negative 18, then I know I need this to be a plus 6. So my 2 factors become x plus 6 and 2x minus 3. So that's just another way of organizing. It's the same concept, just another way of organizing it. So all 3 of these methods are definitely ways that you can factor trinomials where your lead coefficient is not a 1. Those are the ones that tend to give students more trouble. But I hope this was helpful. Now on your Google Doc, you've got a few problems that you can try on your own as you go back and look over this video as a guide.